Okay. One more time. And go. Oh my gosh! It's doing more than we've ever had before. Wow! Oh wow! Wow. Wow! It passed the first surface check. Oh my gosh, it's passing surface checks. This is amazing! This means it's working. Oh wow. Alright, so for reference, we have to ground, to get this to work, I've separated, what is it, motor on B? Yeah. Because this thing is hardwired to be drive 2 or B. We have to tell it, we're manually grounding, separating from the host system and grounding on the drive side. Select B and motor B, full time, so it's always on. And then we grounded on both sides, both host and disk side, pin 34, door open or disk ready change, depending on which 10, 20, 30. It just passed 43. Look at this. Did it? No. There, this is 40. 1, 2, 3, 4, 5. Yeah! 6. Yes, we got it. I can't wait to see what those signals look like, but we got it. Alexander, I told you this worked. You, of course, told me we could do it with a 3.5, so it looks like we were both right. I'm right and you're right, which is a wonderful thing. I love it when it works out like that. Oh my gosh. I've never seen it go this far before. Wow. Jeez! Oh, wow. Yes! It only took months. Okay. Well, at least we can do it with a physical disk, and now we know how. Wow. All right, this is what happens when you put brilliant minds together. Yes, Alexander, I'm talking about you. Thank you. Okay. Now, I want to kill the process as soon as it gets to 4 on the next line. What is that? 10, 20, 30, 40, 50, 60, 70. 1, 2, 3, 4, 5, 6, 7. 77 tracks. That's exactly what it should be. If you start counting with 1, as we do in real life, it's 1 to 77, or 0 to 76. It's exactly what it should be. So I'm going to take this disk out, and I'm going to do it again, and I'm going to kill the process as soon as we get to 76, so that I can see the unwritten, so I can see the surface check by itself without any of the modifications that happen when we're writing volume structures to the disk and doing all this stuff. So let's pull this out. We're going to mark it as complete format, AWS. This is the first one that's ever happened on a 3.5. No, it's the first time it's ever happened for us, period. It just happens to happen on a 3.5. Makes sense, I guess. Woohoo! Okay, so here we go. Just to give the perspective, yes, we are Maxell 2 HD. Okay, 10-pack, yep, you got it. Okay, so that's a fresh one. This is formatted IBM, which is going to be wiped away by this process. And, you know, this is going to be totally different. And we're going to look at the disk structures on this, capturing it with the SuperCard Pro and analyzing it with the HXC software. Oh, yeah. All right, so we're putting this in upside down because I got this thing in upside down. And there it is. Disk motor's on as it should be. Hit F1 on the AWS to redo the last command. And go button. And go button. Now, isn't that interesting? This is the first time I think we've done this with a fresh disk out of the box, and it's finding the header. It looks like it's finding the header from the IBM formatted disk, if you can believe that. Medium is a valid medium. Well, I have a hard time believing it's a valid volume for the IWS, but could it be that standard? And we've been having this much trouble with it all along? Maybe. Well, here we go. Let's go to next page. Okay. That's the rest of it. So we're going to take good notes of this here. As a matter of fact, I'm going to snap a close-up pic with my phone so I don't have to do a lower quality video resolution. Right there. Okay, good. And now we're going to hit go to confirm. And we have to kill it at a very specific time here. So I'm just going to pop the disk out as soon as we get to that point. Wow! Oh yeah, we want that to be lost. It's just standard IBM format out of the box. The fact that you can read it is astounding. See, that's the bizarre thing about this AWS. There are some things about it that conform to the standard that persisted through the decades of the PC, evidently. But then there's these other things that are just so baffling that the foremost disk emulator experts, Alexander and the DREM, it baffles them for months. Baffles me for months. Baffles everybody for months. And what you think is the issue is never actually the issue. That's what we're seeing here. So cool! Oh, come on. Don't hang up on me here. Keep going. Well, this is where it dies. Oh, come on. Don't tell me. Well. I wonder if we have to wipe this thing first. I mean, really wipe it. Because that's the only difference between this disk and the other one, is this one hasn't been wiped a dozen times by various processes. Yeah, I'm not going to go through this because it's clearly going to find errors on every one of them. So let me do that. Let me go through the process of wiping this and trying this again. So I'm going to hit cancel here by hitting action, holding action, and hitting finish on the keyboard. There, operator intervention error 4. Yeah, all right. We're gonna wipe this disk and try it again, because I wonder if the existing things on the disk are causing it just enough problems that it's not getting what it needs to get. Because there are existing magnetic flux transitions on this disk, and if they widen out, some of the old ones might still exist. Seriously. Huh. Just a theory. We're gonna prove that theory out somehow. Here we go. We're going to unplug the SuperCard Pro ribbon cable. We're going to plug in the modified AWS ribbon cable. Okay, and now we're going to power on this floppy. And it's running, good. Let's make sure we still have AWS control because it's been acting funky. We do, so I'm going to hit F1 to redo the test. There it is, good. And go. And go to format. And it's formatting, good. Tracks 0 to 76. Service check. Here we go, good. So far, so good. We count up to 43. $10, $20, $30. Okay, keep going. That should be 40, 41, 42, 43, check 44. Yeah! Come on, keep going. 40, 45, yes, 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 keep going. Yeah, 46. Oh, come on. The fact that we've gotten this far says a lot. Uh-oh. Come on. Well, what I did certainly helped. Maybe we need to wipe it a bunch of times. Notice it's 45, not 43. So we've gotten further even with this. Oh, it's keeping going. All right. Maybe that's a real bad spot. Oh, man. This is awesome. Come on, keep going. That's 52, 3, 53. Come on, come on, come on, 53. Okay, well, it's real disk media. But we're proving out that this can work now for the second time. The system functions past track 43. All right. Keep going. Keep going. Come on, come on, come on. Cheering it on. That's 60. Oh, we're almost there. 71, 2. Wait, whoa. All right, I guess it stopped right as I did that before I ejected it. But hey, this is good enough for me. So let's write on this. Let's write on this and then check it out. Okay? So let's see here. All right, so here's what I wrote. Sector 45, 2. 45 being the track and 2 being the sector of 2 of 16. And only 2 of 16, not 1 and not 3 to 16. Or 0 to 15, depending on how you count. All right, now we're going to analyze this and have a look. So here we go. Let me do a cancel on the AWS here. Just cancel. Cannot load exit run file. Please reinsert system diskette. Well, that's not going to happen. If we have to reboot, we have to reboot. So there we go. Cancel. All right, that's fine. I'm not worried about this. Not right now. So here we go. We're going to put this in. Okay, and we're going to connect the SuperCard Pro ribbon cable, which is right here. We're going to connect it properly to the back side of this floppy. Okay, and we're going to make sure that over here on the computer, SuperCard Pro, it finds the disk, good. We're going to reopen HXC after that. The order is very important because HXC evidently interferes with SuperCard Pro. Now, we are going to source device SuperCard Pro Drive 1, that's right, that's the floppy, and we're going to go to Flux image file, and we are going to click Make Image, and this is going to be the AWS floppy format, third attempt. Surface check 0 to 76. Although we saw it jump ahead those last few, I don't know why. Maybe it doesn't surface check them. Anyway. No headers. Alright, that's our image. And go. Go, go, go. Okay, now we're going to load what we just saw. Here it is right here. Open what we just read. And now we're going to go Track Analyzer. We're going to go to Track View, Dummy Disk. That's beautiful. Look at this. You see these red spots here? That kind of indicates it thinks there's a problem. But the AWS doesn't think they're a problem. Isn't that interesting? And look, it thinks there's problems here as well. But we got no errors there. As a matter of fact, the only error we got is right here, I believe. And if I look at this carefully, I wish I could make this bigger, but I don't think I can. Can I? So what do we have here? It looks like that's a bad spot. Which one did the disk say was bad? It was sector 45, 2. Track 45, sector 2. Well, this is track 45. No, what is it? I can't see. This is sector 8. And that's track 49. So track 45 is there, but now I'm on sector 8. So here's sector 2 right here, 45-2. Hard to get. Sector 45-2 over here on the right. I can't move the mouse, otherwise we won't see what's there. But it'll zoom in with the editing. And track 45, side 0, sector 4. It says sector 4. Okay. So that probably means because sector... Well, no, that's not right. If this is sector 4, then that's sector 1. How does this become... Yeah. Why does it think... Yeah, it doesn't... The sector IDs are all wrong here. 111.5, because these have to be all sector 1, right? You'd think. So the sector IDs are all messed up here in the HXC analyzer, but they've got to be right for the AWS because it worked. So there we go. We can see, you know, the HXC finds errors on these sections, but it actually works. It actually works. And notice again here on in the center, we have these that don't quite line up. See how those inside sectors? Those were not rewritten. So these sectors are the spacing as written by the SuperCard Pro. And notice how it's slightly different as the 16 sectors as they're written by the AWS. Here they line up here at the beginning, number 1. But as we slowly get on down the line, 1, 2, 3, 4, 5, 6, 7. Notice how they diverge just a little bit. This does not surprise me that the SuperCard Pro would decide to write this at a different rate than the AWS, and the fact that it's, you know, the AWS is slower is actually one of the issues, right? And particularly here after track 43, we see all kinds of issues that what's being written is slower and out of bounds, right? Out of boundaries, out of the norm boundaries for normal standards, right? I'm sure it's out of boundaries for normal ANSI standards. But hey, I don't think this machine was conforming to ANSI standards because it was probably, you know, it was originally developed, quite certain it was originally developed before these ANSI standards were quite as rigid as they are now, if they even existed. We'll have to do research on that to verify. Maybe one of our viewers can help with that. Anyway, please let us know in the comments if we're right, wrong about that, and include sources, please. We'll approve your URLs if you post them. Anyway, we have evidence now it's working as designed, especially since it can read after it writes on every single one of these tracks except for one, which apparently is a real issue in the real media. Okay, I'm satisfied. Alexandra, I hope you're satisfied too. And now maybe, if it's possible, we can get the DREM to adjust to be able to accept these kinds of things, because it certainly looks like we have a real-world example of a system that is functioning as designed by its original creators at Convergent Technologies, that is outside the norm of anything we've ever seen before, and yet is functioning as designed. I think that's what we're looking at here. So, thanks so much for watching, and thanks so much for your hard work to make the emulation of the floppy disk for the Convergent Technologies AWS Turbo a reality. Take care. Till next time.